Hi, let's solve this puzzle. You see the numbers 2, 5, 8, 11 and 14. What do you see here? I know you will say 3 is being added every time. Exactly. And that constant addition is the soul of the arithmetic progression. The difference between the consecutive terms is a constant, and that is 3. This is an arithmetic progression. So what is an A? You see here a sequence where A plus D, A plus 2D, A plus 3D, and so on. Here, A is the first term and D is the common difference. The word common is very important because this difference is constant between all the consecutive numbers. D, D, D. For example, 7, 10, 13, 16. So what do you see here? A is equal to 7. That is the first term. And what is the common difference? 10 minus 7 is 3. 13 minus 10 is 3. 16 minus 13 is 3. Don't assume the common difference D is always positive. It can be negative also. For example, let us take one sequence, 20, 17, 14, 11, etc. Here, the first term is 20. Common difference is 17 minus 20, that is minus 3. 14 minus 17, minus 3. 11 minus 14, minus 3, and so on. And AP does not have to always increase. It can also decrease. You can see from here, the common difference D, the constant, can be a positive or can be negative. You can say there can be 3 types of arithmetic progression, 3 kinds of AP. You can write increasing AP, or you can say decreasing AP, or constant AP. Here, D is greater than 0. Here, D is less than 0. Here, D is equal to 0. So you can put example here, like it can be 8, 5, 2, and in constant AP, there you can take one example, 6, 6, 6, 6. The first term is 6. The common difference is 0. Please remember, D is equal to 0 also an AP. This is very important from exam point of view. Now, what is not an AP? That is also very important. 2, 4, 8, 16, 32. The first term is 2, but the common difference is not constant. So this is not an AP. Let us take another example. 1, 4, 9, 16, 25, and so on. The difference between the 2 terms is not constant. The difference of 1 and 4 is 3. The difference of 9 and 4 is 5. The difference of 16 and 9 is 7, and so on. So this is not an AP. This is very important. You see a sequence here, 3, 7, 11, 15, 19. The first term is 3, and the common difference you can see is 7 minus 3 is 4, 11 minus 7 4, and it is so on. The best thing to visualize this is to just plot this, the graph. These are the term numbers, and you can plot here term values. So when you plot the term numbers and the term values, you will find, and once you plot this point, this is like the first term is 3, so you mark here 3. The second term is 7, it is here. Fourth term, the third term is 11, it is here. So when you mark these points, you will find it's a straight line. Here, one difference D controls the slope. If D is greater than 0, the graph is something like this. If D is less than 0, the graph is something like this. And if D is equal to 0, the graph is something like this. Here the graph rises. Here the graph falls. Here the graph is horizontal. Let us take one sequence, D, A plus 2D, and so on. Here the first term is A. The constant difference is D. The common difference is D. So the first term is A, the second term is A plus D, the third term is A plus 2D, and so on. So here, what number is attached with D? With D, it is 1, it is 2 here, it is 3 here, and so on. So my question is, what will be attached with the nth term? It will be n minus 1. Why it is not n? To reach the second term, one jump. To reach the third term, it is second jump, and so on. That is the reason fourth term, it is third jump. Nth term, n minus 1 jump. So we can write the nth term of this sequence will be first term plus the number of jumps n minus 1 and the common difference. So this is a very important derivation. Let us solve this question. Find the 20th term in this AP. So what is the first term? 3. What is the common difference? 7 minus 3, 4. 11 minus 7 is 4, and 15 minus 11 is 4. So difference D is equal to 4. We know the nth term is equal to first term plus n minus 1 into difference. 3 plus 20 minus 1, because 20 is the 20th term you have to find, and the common difference is 4. So this will give you 3 plus 19 into 4. This is 3 plus 76, that is 79. This is the answer. Let's find a term from the end. So the sequence is 5, 9, 13, and so on till 81. Here you notice the first term is 5, and the common difference is 4. And the most important thing, the an, the nth term is given here. So an is 81. You know the formula? An is equal to a plus n minus 1d. Just put the values here. What you get? 81 is equal to 5 plus n minus 1 d. And d is what? 4. When you solve this, what do you get? 5 plus 4n minus 4, which is equal to 4n plus 1. 4n is equal to 80, which implies n is equal to 20. So number of terms in this AP is 20. Please note, when the last term is given in a problem, don't invent a new formula. You can still use this to calculate the things. Got it? Let's find the common difference when two terms are given. For example, the fifth term is 17 and the 12th term is 45. The nth term is equal to a plus n minus 1d. 17 is equal to a plus 5 minus 1d, which implies a plus 4d. This is n taken from here. 45 is equal to a plus 12th term, 12 minus 1d, which is a plus 11d. So this is 1, this is 2. When you solve 1 and 2, what do you get? 7d is equal to 28, which implies d is equal to 4. 17 is equal to a plus 4d. So you can substitute d here, a plus 4 into 4, a plus 16. So 17 is equal to a plus 16. A is equal to 1. The first term is 1. The AP is 1, 5, 9, 13, etc. So what we notice from here, A12 minus A5. A12, the 12th term minus the 5th term is equal to 12 minus 5d. So what is A12? That is 45. A5 is 17. This is equal to 7d, which implies d is equal to 4. So we can generalize this. Am minus an is equal to m minus n into difference. This is a conceptual shortcut you can use if you can remember it to the examination. This is the most important AP formula, the sum formula. Suppose I want to add the first 100 terms, let's say from 1 to 100. What should I do? Should I keep on adding 1 plus 2 plus 3 plus 4 till 100? Or there need to be a shortcut. Sn The sum of all the numbers in a sequence is equal to a plus d plus a plus 2d till plus n minus 1d. You can also write this as the sum of all the numbers is equal to a plus d plus a plus 2d, the last term L. This term can be written as L. Now you reverse it. So Sn is equal to L plus L minus D plus L minus 2D plus A. So you have this, you have this. Add both. What do you get? 2 times Sn is equal to the sum of A, this is A plus L. If you add this, A plus L. If you add this, A plus L. Till the last, if you add this, A plus L. So you will get n times A plus L. Hence, the sum of the numbers is n by 2 A plus L. Wow, this is awesome. This is really good formula. This is very easy to derive. We already know the last term, the nth term. An is equal to a plus n minus 1d. So here what you can do, L is equal to a plus n minus 1d. You can substitute this here. What do you get? Sn is equal to n by 2. You put in place of L, you substitute this. What do you get? 2a plus n minus 1d. Please note it down. This is very important. We just learned the formula for the addition of the numbers in sequence. So let's use this to find the sum of all these numbers. So here a is equal to 2. Difference is 5 minus 2 is 3. 8 minus 5 is 3. So let us take d is equal to 3. And the last term is equal to 50. So sum of the terms n by 2 a plus L. Number of terms not given. 1. So in the exam, if you get this to solve, you have to find the value of n. Then only you can get the answer. So we can write an is equal to a plus n minus 1d. Nth term is 50. First term is 2. Number of terms we don't know. And d is 3. You solve this. 50 is equal to 2 plus 3n minus 3, which implies n is 17. Use this 17 here. So what do you get? N is 17. So 17 by 2. The first term is 2. Last term is 50. If you solve this, you get 17 into 26. That is equal to 442. And that's the right answer. This is a word problem. Suppose a theater has 15 seats in the first row, 18 seats in the second row, 21 seats in the third row. There are total 20 rows. You have to find the number of seats. The total sum will be n by 2, 2a plus n minus 1, the common difference. What is n? 20. That's given. 2a, the first term is 15 plus the number of rows 20. So 20 minus 1. The common difference is d is equal to 3. So when you solve this, what do you get? 10. This is 30 plus this is 57. So 10 into 87. The answer is 870, and that is the correct answer. In AP, if there are 3 terms, A, B, C, A plus C is equal to 2B always. The difference between the neighbors, these 2 neighbors is D, and these 2 difference is D. If you take B minus A, the difference is equal to C minus B. The difference, this is a common difference. This is common. So when you solve this, what do you get? 2B is equal to A plus C. Please remember this. Small thing, but important. Suppose you're asked to solve a problem. If you're asked to choose 3 terms, you can take like this. A minus D, A plus D. 4 terms, you can take A minus 3D, A minus D, A plus D, A plus 3D. Common difference. 2 in the odd term. See, the odd term behaves similar. A minus 2D, A minus D, A plus D, the common difference D. So whenever it's like the if odd terms, the difference is D. And when the even terms, then in the common difference of 2D. Let's take one AP, a decreasing AP. The first term is 50 and the common difference minus 5. When you find the nth term, an is equal to a plus n minus 1d. So this will be an is equal to the first term 50 plus n minus 1. Don't write 5 here. That's my concern. The difference between the numbers, it is 5. But since it is decreasing, you have to take 45 minus 50. It is decreasing. When the AP is decreasing, the common difference is always negative. When it is increasing, the common difference is always positive. Please keep this in mind. This is very important. So here, no 5. You have to take here minus 5. You can expect this question in the examination. Find whether a number is a term in AP. This is a sequence, and my question to you is whether 102 is a part of this sequence or not. Here, A is 7 and the common difference is 5. Nth term is equal to a plus n minus 1d. We will take this as 102. First term is 7, n minus 1, difference is 5. When you solve this, what do you get? 102 is equal to 7 plus 5n minus 5, which is equal to 5n plus 2. 100 is 5n, which implies n is equal to 20. Please note, n is equal to 20. What we have achieved here is a positive integer. 102 is a part of this sequence and it's a 20th term in this AP. Suppose I twist this question a little bit and ask you whether 100 is a part of this or not. An is equal to a plus n minus 1d. 100, this is equal to 7. The first term is 7 plus n minus 1 and the common difference is 5. 7 plus 5n minus 5. This is equal to, so n minus 1 is equal to 93 by 5. This is not an integer. Hence, 100 does not belong to this sequence. This is exam level question. The 7th term is 34 and the 13th term is 58. You have to find the first term and the common difference. A is equal to a plus n minus 1d. Using this, 34 is equal to, so a plus 6d, this is 58, a plus 13th term, so 13 minus 1, common difference d is equal to a plus 12d. This is 1, this is 2. When you solve 1 and 2, get 6d is 24, which implies d is equal to 4. If you substitute this value, so d is 4, 6d is 24, 34 minus 24, so a is equal to 10. You can expect such questions in examination. Here you have to find the sum of the first 25 terms. The sequence is 4, 9, 14, 19, 24 and so on. So you have to find the sum of first 25 terms. N is equal to 25. This is the first term. So A is equal to 4 and the common difference you can check 5. You know the formula. Sn is equal to n by 2. 2a plus n minus 1d. Just put the values to get the answer. N is 25 by 2. A is 4. So this is 2 into 4 plus 25 terms. So 25 minus 1. Common difference is 5. 25 by 2, 8 plus 120. This is equal to 25 by 2 into 128, which is equal to 25 into 64, which is 1600, 1600, and that's the right answer. So kids, today whatever we have studied, we'll conclude it. In the AP, this is a sequence. A is the first term, a plus d is the second term, a plus 2d is the third term, and so on. A is the first term, and the common difference is d. To find the term n, an is equal to a plus n minus 1d. Sn is equal to n by 2, 2a plus n minus 1d. We have also derived. You can refer to that part. Sn is equal to n by 2, a plus l. A is the first term, l is the last term, n is the position. It takes lot of effort to create, edit, and share videos which are very useful to you. So if you really like the videos, please like and subscribe. And don't forget to press the bell icon, because in the next video, I am coming up with entire topic on quadratic equation. So thank you for watching the video. See you in the next class with quadratic equation. Till then, bye-bye.